Hello, my name is Steve Bowler, and welcome to the Juniper Intermediate System to Intermediate System ISIS Lab number 5. In this lab, we're going to take a look at route summarization within ISIS. So if this network topology looks familiar to you, that's because we used it in our ISIS Lab number 2, which was multi-area ISIS, and that was part of Juniper Series 2. So what we're going to do is we're going to use that same network topology. We've just added some prefixes to our loopbacks on router 5 and router 4. For those of you that did not watch that video yet, what I'm going to do first is explain our current network topology. What we have configured is all of the interfaces and initial IP addressing. So the first thing that we're going to do is configure ISIS on all of the devices, and then we're going to take a closer look at route summarization. So first off, all of these routers are logical systems. They are connected together via logical tunnel interfaces. If you're not familiar with those terms, I would suggest watching Logical Systems Labs number 1 and 2, that's part of Juniper Series 1. And what we have is all logical tunnels equal LT-120.XX. What this means is, for example, from router 3 to router 5, that connection we have abbreviated at LT.35. That is actually LT-120.35. All the router IPs are for router 1.1. That's all of the interfaces, including the loopback. That's the 4th octet IP. Router 2 is .2, and etc. down the line. So when we get to the loopbacks on router 4 and router 5 that we're going to be doing route summarization on, let's take, for instance, the loopback 0.5, the subnet 172.16.3.0. The actual IP address is 3.5. And on R4, loopback 0.4, 192.168.1.4. So we have the networks between R1 and R2. That link is 12.12.12.0/24. The link between R1 and R3 is the 13 network. The link between router 2 and router 4 is the 24 network. And the link between router 3 and router 5 is the 35 network. And the logical tunnel interfaces associated with the routers are very simple to follow. On R1 to R2, that logical tunnel is LT.12. Router 2 to router 1 is LT21. Router 1 to router 3 is LT13. Router 3 to router 1 is .31. Router 3 to router 5 is LT35 on R3. And R5, it's LT53. Router 2 to router 4, logical tunnel 24. Router 4 to router 2, from router 4's perspective, is logical tunnel 42. And so we have router 1 in level, it's a level 2 router only. Its interfaces are in level 2. Router 2 and router 3, they are the equivalent to, in OSPF, an ABR, our area border router. They are in both level 1 and level 2. Their level 2 interfaces are pointing to router 1, and their level 1 interfaces are pointing to router 4 and router 5. So router 4 is a level 1 only router, and router 5 is also a level 1 only device. The areas, we have 3 of them. Router 3 and router 5 are considered in area 35. Router 2 and router 4, they are in area 24. and router 1 is in area 1. We have lots of networks on our loopbacks that are at the edge on the level 1 routers. Router 4, we have 4 prefixes. We have 192.168.0.0, 1.0, 2.0, and 3.0. On loopback 0.5, on router 5, we have 172.16.0.0, 1.0, 2.0, 3.0, 4, 5, 6, 7, and those are all /24s. So what we are going to do is we're going to summarize these networks in this video. So the first thing, let's go ahead and get ISIS configured. Let me also just add our net addresses. If you're not familiar with the net address, you can watch ISIS lab number 1 that's on Juniper Series 2, which explains the net address in detail. Let me just tell you what the net address is. For instance, for router 1 we have 49.0001. So the first section where we have 00XX, that's going to give us our area. So that's 0001, and then we have 0010, 0100, 1001.00. So that's going to be the net address for router 1. We're going to assign that to the loopback. So each router in ISI that participates in ISIS routing must have a net address configured. And for router 2, that would be 49.0024, 0020, 0200, 2002.00. So there's a loopback on all of these routers. Router 1 is 1.1.1.1, router 2 is 2.2.2.2, etc. So let's go ahead and get into the configuration. Start with router 1. We're going to do the initial ISIS configuration. We do set interfaces loopback 0.1 family ISO address, and this is where we configure our net address 49.0001.0010 dot 0100.1001.00. Then we'll do set interfaces LT-120.12 family ISO. So we have to enable ISIS underneath the interface. So we'll do that for interfaces 12 and 13, the logical tunnels on R1, going to router 2 and 3. Then underneath the protocols, we'll do set protocols ISIS level 1 disable. So this is going to make router 1 a level 2 router only. Then we need to also incorporate underneath the protocols ISIS hierarchy, we have to incorporate our interfaces. So interface loopback 0.1, these are going to also be participating in ISIS. So LT-120.12 and 13. So that's it. That's the initial config on router 1. We'll go ahead and continue on router 2. Set interfaces loopback 0.2 family ISO address 49.0024 0020 0200 2002.00. Set interfaces LT-120.21 family ISO, that's the connection to router 1. Then we'll also put in logical tunnel 24, that's the connection to router 4. Now we go under protocols ISIS, advertise our interfaces, so we'll do interface loopback 0.2. Also do our logical tunnel interfaces 21 and 24. So pretty straightforward. Once you configure IS several times, this should be pretty quick and easy to do. Now these routers, router 2 and 3, we're not disabling any of the levels because they are again level 1 and level 2, which are the default IS router types. So in R3 we'll do set interfaces loopback 0.3 family ISO address 49.0035 0030 0300 3003.00. We'll do set interfaces logical tunnel 120.31 family ISO. That is for ISIS, and then 35. That's the connection to router 1 and router 3. I'm sorry, and router 5. Set protocols, ISIS, interface loopback 0.3. Then we want to do actually, you know what I forgot? I apologize. On router 2, we actually do have to, we're going to disable on our link to router 4, we're going to disable L2, and then on our link to router 1, we're going to disable level 1. So if you were wondering why I said that before, that is false. What we actually have to do, and I just caught it, on router 2, we'll go back, we'll do set protocols, ISIS interface, and then under 21, we're going to do level 1 disable. That's the connection to router 1. We're going to make that strictly a level 2 interface. And then we're going to disable level 2 on our connection to router 4. So I apologize for that. Let's go ahead and commit that. Just caught that while we were configuring router 3. The logic on router 3, we'll do set protocols ISIS interface LT120.31. That's the connection to router 1. We're going to disable level 1 and make that strictly level 2 connection. And then our connection to router 5, we're going to disable level 2 because we want it to be a level 1 link. Okay, let's move to router 4. We'll do set interfaces loopback 0.4 family ISO. Address is going to be 49.0024 0040 0400.4004.00. Then set interfaces LT120.42. Is that right? Yeah, that's right. To router 2, we'll do family ISO. And we're going to do set protocols ISIS level 2 disable. It's going to make this router strictly a level 1 device. We'll do set protocols ISIS interface loopback 0.4 and logical tunnel 120.42. So the last router, then we will be done with our initial ISIS configuration, router 5. Set interface loopback 0.5 family ISO address 49.0035 0050 0500 5005.00. We'll do set interfaces, logical tunnel 120.53, family ISO. Set protocols ISIS level 2 disable, make router 5 strictly a level 1 device. Set protocols, oops, I don't know what happened there, sorry about that. Let me go back to router 5. Set protocols ISIS interface LT120.53 and set protocols ISIS interface loopback 0.5. Alright, that should be the initial ISIS configuration done on all the devices. What we'll do next is we will confirm that our ISIS adjacencies have been formed, and we'll ping from loopback to loopback on R4 to R5. So we'll go to router 2 and we'll do a show ISIS adjacency. We have a connection to router 1 and router 4. Router 3, show ISIS adjacency. We also have an adjacency with router 1 from router 3 and also to router 5. So let's go to router 4. We'll do a ping 5.5.5.5, source that from 4.4.4.4. We'll do a rapid count of 100. And you see we have reachability. So also from router 4 we'll do a ping to one of the loopbacks on router 5. We'll do 172.16.7.5. And we'll source that from one of our loopbacks prefixes other than the 4.4.4.4. We'll do 192.168.0.4. And we should be good to go. There you have it. Let's go to router 5. We'll do one more. Ping 192.168.2.4, and we'll source that from our own loopback prefix 172.16.3.5. Let's look at our network diagram and show you what we're doing. On R5, we are sourcing our ping from the 3 network, 172.16.3.5, and we're pinging the, I believe, the 2.4 on router 4. So we'll do a rapid count of 100, and we have reachability. So from router 4 and router 5's perspective, we have reachability to all throughout the network. If I do a show route on R5, see that we have all the directly connected networks. But if we do a show route protocol ISIS, we are receiving the default route from router 3. So that's coming from the L1, L2 router, in this case router 3 from router 5's point of view. If I go to router 4, do a show route protocol ISIS, I see the exact same thing. I see a default route coming from router 2, which is the closest L1, L2 router. So that is the default behavior. The L1 routers will receive the default route from the closest L1, L2 router. In this case is router 2 and router 3. But if we go to those L1, L2 routers on R3, if we do a show route protocol ISIS, you can see the routing table. We have all of the loopbacks We have the attached networks, the 12 network, the 24 network. We have the 172.16 networks from router 5, and we're also seeing the 192.168 networks. Let's do the same thing on router 2, show route protocol ISIS. Looks like we have all of these networks in the routing table, in the ISIS routing table. All the 192.168s, the 172.16s, the loopbacks. Let's do that on R1 as well. So we have all the 172.16s, the 192.68s. So we can clearly see that the routing tables on the L1, L2 routers and the L2 router, router 1, are very large and will continue to grow as routes are added to our network. One way we can combat against this is to use route summarization and summarize these routes on the border routers, which are router 2 and router 3, so that only summarized routes will be flooded throughout the level 2 or L2 backbone. So we're going to implement this and we're going to start this by summarizing all the 192.168 routes on router 2 that R4 is sending us. And we'll send this summarized route to the L2 backbone. So this is going to be done on router 2, and we're going to accomplish this by creating a simple routing policy that will be broken out into two terms. In the first term, we will use a route filter which will match the summary route or the aggregate route going specifically to ISIS level 2. And the second term will be created to deny all more specific prefixes. So I know that sounds like a lot. Let's go ahead and get on the router 2 and break this down for you step by step and show you exactly what we're doing. First thing we're going to do, we'll create this routing policy. We'll do set policy options, policy statement. We'll just call this summary. And the first term we're going to create, we'll just call it the summary route. And this is going to match, we'll do the from protocol aggregate. Then we'll do set policy options, policy statement, summary, term summary route, from, and then we'll just create the route filter which matches the summary route exactly. So we'll do 192.168.0.0/22 exact. So if we look at our summarization, 192.168.0.0, 1.0, 2.0, and 3.0 can be summarized from a /24 into a /22. So that's exactly why we have that route filter 192.168.0.0/22. So the next item we'll do set policy options, policy statement, summary, term summary route. So it's the same term, and we'll use the to option, and we'll specify, if we do a question mark, we can specify exactly what we want, where we want this summarization to take place, and we want it to take place into level 2. That's the backbone of ISIS. So the last thing we need to do within this term summary route is we just need to create our action, which is to accept. So if I do a show on R2, what we just created is the policy option, the routing policy called summary. Our first term is called summary route, in which we are matching the protocol aggregate and the route filter 192.168.0.0/22 exactly, going to the ISIS level 2, and we're going to accept. And so our next term, the second term, so we'll do set policy options, policy statement, summary. Our second term will do prevent specifics from protocol aggregate so we're matching the aggregate. Then we'll do from route filter, we'll do the exact same route filter 192.168.0.0/22, but instead of exact, this time we'll do the option or longer. So all other more specific prefixes is what we are matching. Then we'll do set policy options, policy statement, summary, term, prevent specifics to ISIS level 2. And our last action, our last statement is our action item, which will be then reject. So our first term, we're going to match the 192.168.0.0/22 exactly, and we're going to send this to level ISIS level 2, and we are accepting it. The second term, we are matching the aggregate once again from the exact same network 192.168.0.0/22, but everything more specific is what we are saying with the or longer option. To level 2, we are going to reject. So let's go ahead and commit. Let me just say once again that the to statement ensures that the summary is not sent to level 1 area. So let's go ahead and apply this routing policy. We'll do set protocols ISIS and we'll just export it. We'll do export summary. So before we verify that our summary route, we must generate or define the aggregate on R2 to begin with. Oops, let me do this. Let's go ahead and commit. If I do a show route, the 192.168.0.0/22 does not exist. So there is no way we can create a summary route for this network without it actually existing in our routing table. So that's what we'll do next, and it's very simple. We'll just do set routing options, aggregate route 192.168.0.0/22, and we'll just put discard. So as we showed you, after we committed the routing policy and the export of this routing policy into ISIS, the 192.168.0.0/22 did not exist in the local routing table. We created the aggregate route. Let's go ahead and commit, and we will quit. And then we will look on R2. If I do a show route, we can see the 192.168.0.0/22 network now exists. And the more specific routes are still showing up in router 2 because they are being learned through the R2 R4 adjacency, which is a level 1 adjacency. But let's go ahead and look. If we look at R1 and R3, we should see that these specifics have been suppressed and are no longer existing within the L2 backbone. So let's go ahead and go first to router 1. We'll do a show route protocol ISIS. We can see the 192.168.0.0/22 summary that we created, but we can also see the more specifics. Let's check our configuration one last time on R2. Show configuration. Make sure that we have everything in correctly. It looks like it's in there correctly. Let's go to router 1 again. Looks like they're still showing up. Let's see what router 3 shows. Still showing all the more specific, the more specific prefixes. Looks like I found what the problem is. Looks like we have or longer as our option. We actually need just longer. So let's do this on R2. Let's change this to so we'll delete that or longer statement and we'll just put in longer. Let's go ahead and commit. Actually, let's do a show on router 2. Give ISIS some time to converge those routes. Apply those to that routing policy. So what the or longer means is that it's equal to or greater than. We don't want to say that in our routing policy. We want to catch just everything that's longer than these /22. So let's go ahead and check router 1 one last time. If we do a show route, looks like they're still there. Let's check one last time, make sure everything looks appropriate. We have the, let's do one last thing, we'll do a clear. We'll clear the adjacency, and on R1 if we do a show route. Okay, sorry about that. Looks like we have captured exactly what the problem is. If we, on router 2, this is a good time to learn, I guess, is under our policy option, under our term prevent specifics, we have from protocol aggregate, and that's not what we want. We want from protocol ISIS. So looking back at my notes, I'm not sure why I included the protocol aggregate, but we want to match these routes from ISIS and then suppress them. If we look at the routing table on R2, the 192.168 networks are being learned from ISIS. So I'm not sure why I put from protocol aggregate. So back on router 2, let's do this. If we look at the set policy options, policy statement, summary, term, prevent specifics from protocol aggregate, we want to change that to from protocol ISIS. Let's commit that. We'll do a show to verify that. So we have aggregate and ISIS. Let's get rid of the aggregate. Since that's meaningless to us, these routes are coming into router 2 learned via ISIS. So we want to match the protocol ISIS, and we want to apply the route filter 192.168.0.0/22 longer so that those /24s are matched to level 2, and we want those to be rejected. Go back to router 1, do a show route, and bingo. The more specific /24s under the 192.168 prefix have been suppressed on router 1. Let's go to router 3, make sure that this is being propagated from router 2 to router 1 to router 3, since those routers all have L2 interfaces. We'll go to router 3 and do a show route protocol ISIS, and we notice that there are no longer any /24s for 192.168. We did see before on R3 when we did a show route protocol ISIS, we saw those more specifics for 192.168 0.0, 1.0, 2.0, and 3.0. So after our summarization was applied on R2, we see that we only have the aggregate route, the 192.168 0.0/22. So the routing tables on routers R2 and R3 and R1 have been downsized. So last thing we would do is make sure that we can still ping the more specific routes that are now being summarized on R2. So we'll go to router 5, and we'll do a ping 192.168 2.4, and we'll source this from 172.16 3.5. We'll do a rapid count of 100. So we are pinging the more specific prefix that doesn't show up in the level 2 L2 backbone any longer. And we have reachability. So we have reachability to the 2.4. Let's also ping one more. We'll do 1.4. And we have reachability there as well. So we have successfully summarized the 192.168 0, 1, 2, and 3 networks, all /24s on router 4 on R2. Sent that summary to our L2 backbone, and we verified we have reachability to the more specific networks. Last thing we want to do, finish this lab, is by summarizing all the 172.16 routes on R3 that R5 is sending, and send it to the L2, our level 2 backbone. So we'll do something very similar to what we did on router 2, but this time we'll do this on router 3. So we'll create a routing policy first. We'll create those two terms. We'll do set policy options, policy statement, summary, and then our term we'll call summary route. We'll do from protocol aggregate. This time our route filter is going to look a little different. We're going to use 172.16.0.0/21 exact. So if we look at these routes, we have 8 networks. We have 172.16.0, 1, 2, 3, 4, 5, 6, and 7. Those are all /24s. And we know by our awesome subnetting skills that can be reduced into one single 172.16.0.0/21. So that's where we came up with that route filter. So we are going to use the to statement. This is going to ensure the summary is not sent back to level 1, but to level 2. Once we have that in place, our last item within this term is going to be to accept. So the first term is done. Let's go ahead and create our second term. This time we're going to get it right. So we'll do set policy options, policy statement, summary, term. It's going to be prevent specifics. From protocol, ISIS. Then we'll do from route filter 172.16.0.0/21, and not or longer, but just longer. Going to level 2, which is our backbone. And then our action item is going to be to reject. Last thing we need to do is apply this routing policy to ISIS. We do that with the set protocols ISIS export, then our routing policy, which is summary. Let me just commit that. We'll quit. And I'll just explain a couple things before we create our aggregate route. If I do a show route, we see the 172.16 networks, all 8 of them, coming in via ISIS. So if we do a show configuration, that's why we created our routing policy this time correctly that matches from protocol ISIS and not aggregate. So it's coming from, being learned from ISIS. Once it hits this route filter, which matches all the more specific prefixes, going to level 2, it's going to reject all these routes from going to the L2 backbone. And the /21, once it's matched via the aggregate that we are going to inject now into the routing table, we do set routing options aggregate route 172.16.0.0/21 discard. Once this is matched, this /21 is going to replace all the more specific prefixes. So that's it on R3. If I do a show route, we can verify that we have the /21 in our local routing table on R3. We also see the more specifics. That's because those are coming to us via our L1 peer, router 5. Where we should see the major change is on router 1 first. Show route on R1, we'll do show route protocol ISIS. And it becomes very clear that all of the more specific 172.16 networks, all 8 of them have been suppressed. Before, they took up a large portion of our routing table on R1, and though they no longer exist, so all we are receiving is the summary from router 3. Let's look at router 2, the other router that has a L2 interface. Make sure that we are seeing the same thing. Show route protocol ISIS, and that's it. We're just seeing the 172.16.0.0/21 and none of the more specific routes. Let me just also add that this is coming in with a route preference of 165, which is ISIS level 2 external. So by summarizing our level 1 routes at the L1, L2 border router, this has significantly decreased the size of our routing tables for the L2 backbone. And we still have reachability to the more specific prefixes. Let's test from R4. We can ping some of the more specific 172.16 networks that originate from router 5. We'll do ping 172.16.7.5. We'll source this from 192.168.0.4. We'll do just a rapid count of 100, and we have reachability. Show route on R4 shows that we just have the default route, none of the more specific prefixes. That default route coming to us from router 2, the closest L1, L2. Let's do another ping. This time from 1.4. Let's ping 5.5, and we have reachability. This time we'll ping from our 3.4, and we'll ping the 2.5. So what we're doing on router 4, let's take a look at our network diagram. We're sourcing our pings from our own loopback networks, and we are pinging the more specific prefixes that are on router 5. So router 3 has summarized all of these 8 networks into 1/21, sending it to router 1. Router 1's also passing this information to its L2 neighbor, router 2. So we're just showing you that we still have reachability. So that's it. That's Juniper intermediate system to intermediate system, ISIS Lab 5. We showed you how to summarize routes. We did this on the L1, L2 routers, router 2 and router 3. Let's take a look at one of those examples real quick. Just to show you what this looked like, we do show configuration on R3. We created a routing policy which matched the protocol aggregate. The aggregate we had to add, which was 172.16.0.0/21. So we had to generate this route in our local routing table in order to create this aggregate to match on. We created a route filter to match that aggregate route exactly. This was going to level 2 from router 3's perspective. It's linked to router 1. So as the level 1 routes come to the L1, L2 router, we matched all of them with the aggregate route. And what we said in our first term, going to level 2, we want to accept the exact or just d/21. Our second term we created to prevent the specifics that's correct. The more specifics from being advertised. We did this by matching them so they are being learned on R3 from protocol ISIS. We initially made that mistake. We we said from protocol aggregate. We knew that was wrong. So we quickly changed that to ISIS, and we saw that the change was correct. The route filter rematched 172.16.0.0/21 longer, so anything longer than a /21 going to ISIS level 2 is going to be rejected. So that's it. Thanks for watching, and I hope to see you in the next video.